Welcome to Maths with EJD. In this video, I'll be talking about chi-square test, which is the last non-parametric test I'll be talking about. That doesn't mean that there are only four non-parametric tests, no, but these are the four I'm taking here. These are like the top four or something. Just like I took four for the parametric tests. So if you want more of this, don't forget to subscribe to this channel. Hit the notification bell also so you can always get alerted. So you can always be alerted, right? When a new video is released. So test, the chi-square test is a statistical method. The statistical method used to examine whether there is a significant association between two categorical variables, So, I mean, if you're dealing with categorical variables, something maybe you just the variables you have are things like that are not numbers per se, not numeric. Maybe it's things like male, female, uh, tall, short, things like that. That's where chi-square comes in. So you have a test for things like that, so categorical variables. So the chi-square test is a statistical method used to examine whether there is a significant association between two categorical variables. It is commonly applied. It is commonly applied when data, when data, when data are in the form, in the form of contingency tables. Contingency tables. The test assesses whether the observed frequencies, for categorical variables, you're talking about how many times you have this or that. So the test assesses whether the observed frequencies in the table differ differ significantly from the expected frequencies under the null hypothesis. Under the null hypothesis, which assumes that there is no relationship between the variables. So that's the null hypothesis. There's no relationship between the variables. Okay. Let me go this way here. So let's talk about the types of chi-square tests. So we have two kits. Okay. Um, there are two main types of chi-square tests. So first of all, you have the chi-square test for independence. Chi-square test for independence. Okay. And then that is so here it determines if two categorical variables, if two categorical variables are independent or related. So that's chi-square test for independence. Two, you have chi-square goodness of fit test. Goodness of fit test. So this determines if a sample matches an expected distribution. So here we will focus on the first type as on the chi-square test of independence. So let's talk about the hypothesis. So hypothesis in the chi-square tests for independence. So first, the null hypothesis. Null hypothesis H naught. So here we just say the two variables are independent. The two variables are independent. That is, there is no association between them. There's no association between the two variables. That is okay. Then we go for the alternative hypothesis. Alternative hypothesis. That's HA, right? So here we say the two variables are dependent. The two variables are dependent. That is another way of saying there is an association between them. So there's an association between the variables. Okay. Let's take an example. Example. Don't forget the focus is on chi-square test of independence. Chi-square test of independence. So suppose a researcher wants to investigate whether there is an association between gender and preference for a new product. So a survey was conducted, and the results are summarized in the following contingency table. So here now we have gender, we have preference for products, or should I say product preference? Product preference. Or should I put it this way? Um, preferred product, then do not prefer products. And then we have total. So this way. So this is the contingency table now. So we have male. Male, you have 30 male that prefer the product, 20 that do not prefer the product, and total is 50. And then we have female, gender. Then 50 prefer the product and 30 do not prefer the product. Total is 80. Then we can do total uh, for each gender like that. So those who prefer the product, they are 80. Those who do not prefer the product, they are 50. While the male are 50 and female are 80. And then, so across the groups, 80 plus 50 is 130, 50 plus 80 is also 130. Okay, let me write that 130 and put it in a kind of circle. So that's the contingency table from the research. So you see that the researcher will perform a chi-square, test for independence, to determine whether the preference for the product is independent of gender. Okay. So let's go for the step-by-step calculation. Here, the first step is to set up the hypothesis. Set up the hypothesis plural. So we have H naught to be such that there's no relationship. There is no relationship between gender and product preference. Then the alternative hypothesis is that there is a relationship. There is a relationship between gender and product preference. Okay. So we have the next step, step 2 now. Step 2, we want to calculate the expected frequencies. The expected frequencies for each cell. Under the assumption that the null hypothesis is true. So the expected frequency for each cell is calculated using the formula EIJ is equal to row total times column total divided by grand total. For example, the expected frequency for males who prefer the product, that is cell 1, 1 would be this. So here now we're doing the cell male who prefer the product, that's cell 1, 1. Male who do not prefer the product, that's cell 1, 2. Female who prefer the product 2, 1, then 2, 2. That's how the cells go. Okay. So in that case now we can compute, say we can compute E11. E11 is equal to row total. So the total for that row, the total for the row is 50. The total for the column is 80. So this is row total, and this is column total for that cell, column total. Then over the grand total, this is what you call the grand total now. Grand total. So that E11 is row total 50 times column total 80, whereby grand total 130. And if you evaluate all that, you should have like 30.77. Please double check that to be sure that it is correct. So similarly, the females, in fact, let's do for the rest. Let's do everything. So I just don't want to jump anything. Okay, similarly, the males who do not prefer the product, who do not prefer the product would have the expected frequency, the expected frequency don't forget that is E12, right? E12, row 1, column 2. That's E12. So again, the formula is row total times column total. So the row total for that is 50. The column total is 50 again. So that's 50 over 50 times 130. It's 50 times 50 divided by 130, the grand total. So let's check that out. This is 50 over 50 times 130. 50 over 50, okay. 50 times 50 rather. 50 times 50 divided by 130. So that is 19.23. This is 19.23. So the expected frequency for females who prefer the product is now E21 E21, which is equal to row total, the row total for women, for female is 80, the column total, the row total here is 80, the column total is also 80. For female who prefer the product, that is 80 divided by 130, the grand total. 80 times 80 divided by 130, and that is 80 by 80 divided by, that's 80 times 80 divided by 130. That is 49.23. 49.23. And lastly, the expected frequency. The expected frequency for females who do not prefer the product, who do not prefer the product, is E22. E22. So again, we have the row total for females who do not prefer the product. This is them here. So the row total is 80, the column total is 50. That is 80 over 50. 80 times 50 divided by 130. 80 multiplied by 50 divided by 130, and that is equal to 80 over 50 divided by 130. That's 30.77. 30.77. So that's how all of that works. And then we have the new table for the expected frequency. So we can say that the expected frequency table, since we calculated all that, the expected frequency table will be, now let's go, we have gender, prefer products, because that's their expected now, expected frequency. So what we had initially would be called the observed different frequency. So do not prefer products, do not prefer products, still the expected in this case. And then we have the total, because that's the total frequency normally, not the expected total, expected. And the total frequency we had originally, that's what this total will be about. So here you have male. So 1, that's 30.7 if you remember. Yeah, 30.7. That's 30.77. And then male who do not prefer the product, that is 19.23. 19.23. Then we have female. Female who prefer the product is 49.23. 49.23. Female who do not prefer the product, that is 30.77. 30.77. Of course, the totals you are going to have there, the normal totals from the original table. So forget the total. This is 80, 50. This is grand total is 130. This 50. This 50, 80. So the grand total is 130. So with these expected frequencies now, we can now compute the chi-square statistic. So that step, what step now? Have I been numbering the steps? Yeah. So here now, I have the step 3, compute the chi-square statistic. And that is this, because chi is a Greek letter, So chi-square summation OIJ minus OIJ minus AIJ all squared divided by EIJ. So what does this mean? OIJ is the observed frequency. That's observed frequency. EIJ is the expected frequency for each cell. Expected frequency. So like that. So we can go step by step now and say that for the male who prefer product, male prefer product cell, we have chi, that's chi1 squared, which will be, the observed frequency is the original frequency we got from the original table. The observed frequency will be 30, whereas the expected frequency is, I think, 30.77. So we have 30 minus 30.77 squared divided by 30.77. I believe that should be something like 0.019. Please confirm and be very sure. Confirm and be very sure of that. So then we go for female who do not prefer products. Okay, I guess I have to really, patiently work this out so that everything can make sense. Okay, so we have 30 minus 30.77. Okay, that's equal to something minus, so that's minus 0.77. Then times minus 0.77 also. That's okay. I think that's not working. Minus 0.77 times times. Okay, we know that will be plus, right? 0.77. So let's do that again. 30 minus 30 minus 30.777. That's minus 0.77 squared divided by 30.77. Guess I can now do that straight. So that is minus 0.77 squared minus 0.77 squared divided by 30.77. Okay, that was correct. 0.0193. 4 decimal places. So that's male who prefer products. So that's next for the male do not prefer products. Do not prefer product cell. So we can call that chi2 squared. We can say that is chi2 squared. Or more, let's do chi1, let's call it chi1 squared. Yeah, for consistency with the cells. So for the male who do not prefer product cell, that would actually be chi. Okay, let me do that the fancy. Okay, that's chi 1, 2 squared, which is, that's observed minus expected, right? The expected is 19.23. The observed is 20. 20 minus 19.23 squared. So that is 20 minus 19.23 squared divided by the expected, right? Divided by the expected, which is 19.23. 19.23. So that would be, okay, it seems the value would be the same all through, isn't it? It's looking like that. Let me see. Because it looks like this is also going to be minus 0.77. Just do that straight. Because 20 minus 19.23 should be that, right? 20 minus 19.23 all squared divided by 19.23 to save time, 19.23. Okay, I think it's different now. 20 minus 19.23. So that is really different. That is 0.0308. That's for the male. Do not prefer product cell. Then next is for the female. Prefer product cell. Prefer product cell. So we can say that is chi 21 squared. So chi 21 squared now. That will be female. Prefer product 49.23 expected. Then 50 observed. 50 minus 49.23. 50 minus 49.23 divided by 49.23. Don't forget this is squared. I'll do that straight again. So that's 50 minus 49.23 divided by 49.23 divided by 49.23. 50 minus 49.23 divided by all squared, right? Divided by 49.23. So that is 0.0120. Okay. Then we go for the female. Do not prefer product cell. So again, we have that'll be chi squared of 2. So that'll be expected. That'll be E22, right? Minus O22. So the expected, O22 rather. So the expected is 30.77. The observed is 30. So observed 30 minus expected 30.77. Okay. Really? How is it the same? Let me see. Okay, 30.77. Okay. Like across. Okay. Just the same. That's the same like the first one. So makes it easy. So that's 30 minus 30.77 all squared divided by 30.77. And that would be equal to what we have up there, which is 0.0193. 0.0193. So with all these components in place now, we can just sum up everything. We can sum up all that, and that will be so I mean, just to emphasize, right? Okay, I mean, there's no point. Like this chi squared 1 is simply from the formula, right? That will be observed 1 minus expected 1 divided by expected 1. Of course, the top is squared. So that's exactly what we are doing there. So now we can have the overall chi-squared. So we can do therefore chi-squared is equal to chi-squared 1 plus chi-squared 1 2 plus chi-squared 2 1 plus chi-squared 2 2. So that chi-squared now is equal to, so chi-squared 1 is 0.0193. 0.0193 plus the next one is 0.0308. 0.0308, sure. 0.0308 plus the next one is the 0.0120. 0.0120. And lastly, we have 0.0193 again. 0.0193. So carefully, we sum that up and see what we get. 0.0193 plus 0.0308, 0.0308 plus 0.0120 plus 0.0193. Let me be sure of that. 0.0193 plus 0.0308 plus 0.0120 plus 0.0193. So all of that will be 0.0814. So that is the test statistic. So you can as well call that chi-squared test. Okay. Then I'm sure the next thing we're going to need to be degree of freedom. Then we go chi-square critical and all that. So the next step, which is it's step 3 we've been doing so far. Let's do step 4 now. Step 4 is to determine the degrees of freedom. Determine the degrees of freedom. So determine the degrees of freedom. So the degrees of freedom for a chi-square test, of independence are given by, okay, guess I'm gonna change the color there. So it's given by degree of freedom equals number of rows minus 1 multiplied by number of columns minus 1. So in this example, the degree of freedom will simply be 1. DF will be number of rows, that's 2. We have 2 rows and 2 columns. That's from here, right? So the actual values, we don't count the total now. So we have row 1, okay. This row 1, row 2, column, row 1, row 2, right? This is row 1. Or I mean this better. So 1 2 1 2. So 2 rows, 2 columns. So the degree of freedom will just be 1. 2 rows, 2 columns. So you have 2 minus 1 multiplied by 2 minus 1. That will be 1 by 1, which is 1. Simply, that's the degree of freedom. Now we go for step 5. Step 5. Step 5. So we can find the critical value. Find the critical value and make the decision and make the Okay, let me just stop at find the critical value first. Then we'll make this decision in the next step. So using a chi-square distribution, a chi-square distribution table, and a significance level, and a significance level alpha of 0.05, the critical value for 1 degree of freedom is about 3.841. 3.841. So this is not like the what I can call the chi-squared critical, so to speak. Chi-squared critical. So now the let's go for the decision now. That's step 6. Step 6. Step 6, make the decision. Make the decision. So what's the decision rule actually? So we compare the calculated calculated chi-square statistic as the test statistic. Compare the calculated chi-square statistic with the critical value. Okay. If chi-squared, if chi-squared, uh, let me put it this way. If chi-squared test, that's the test statistic, is greater, is greater than, if chi-squared test is greater than chi-squared critical, yeah, chi-squared critical, and you reject the null hypothesis. Reject the null hypothesis. I think it's usual that once what you calculate is greater than the critical value, you reject the null hypothesis. But I think in the case of the Wilcoxon signed rank test, it's if it's greater, you accept something like that. I think that's the only one that's different a bit. If I got that right. Okay, so that's the first situation. Then if chi-square test is less than or equal to chi-squared critical, then you accept or fail to reject, the null hypothesis. The null hypothesis. Okay. Now, let's make the decision then. Since we know the decision rule, let's remind ourselves that from what we have, right? Chi-squared test is equal to, I think, 0 point something. That's 0.0814. 0.0814. Okay, I've gone very far. Okay, 0.0814. That's the chi-square test. And then the chi-square critical that's what you get from your table. So you have to get used to your table and really master it. And then some of the things I have here, you have to double check to be sure this is right. But even if I'm not right, just be sure you get the right reading from your table and then just follow the rules. So chi-square critical is 3.841. So, and what is the decision rule? If chi-square test, the chi-square test is clearly less than the chi-square critical. So it falls in the second category. So we do not reject the null hypothesis. That's we accept the null hypothesis. So we can say that since chi-square test is less than chi-square critical, clearly so, since chi-square test is less than chi-square critical, okay, since it is less than chi-square critical, then we it's less, right? Yeah, so we fail to reject. So we fail to reject the null hypothesis. Fail to reject the null hypothesis. What that simply means is that so we say therefore we therefore there is not enough evidence. There is not enough evidence to conclude that gender and product preferences, gender and product preferences or product preference are related. Okay, so we accept the null hypothesis that gender and product preference are independent. Gender and product preference are independent. Okay, so I mean, if you're on that campaign, then you can see that there's the gender doesn't have anything to do with preference for products. So you can see that in this example, the chi-square test for independence shows that there's no significant relationship between gender and preference for the new product. The chi-square statistic, which is 0.0814 in this case, is less than the critical value 3.841, leading us to accept the null hypothesis. Thus, we conclude that the product preference is independent of gender in this sample. So you don't have to do anything special for any gender because we don't have any evidence, at least going by this test, that there's any connection between gender and product preference. So if you want to keep listening to this kind of getting this kind of interesting lessons, be sure to subscribe to this channel, hit the notification bell so you can always get notified each time a new video is released. And don't forget to comment, tell me the question, if you want me to teach a particular topic or answer a question, then like and also share so that more people can have access to this. Till I see you again. Have a nice time. Bye.